So just a recap of solving equations, and we've done this in the first 2 units, radicals and rationals. If we have a single x, we're going to use algebra, move the 7 over, do the same thing to both sides, and then divide by 5. And we get one solution. There's a single x, there's a single solution. If we have an x squared, we're going to put everything onto the same side to get an equal 0. And once we have the equal 0, and this is when we have x squared, we are going to factor it, and we get 2 solutions. So the x squared gets us 2 solutions if we can factor it. If we have a single x, we just use algebra to solve it. Now the problem is, what if we can't factor it? And that's where we're going with complete the square. So just to show that we can do both methods, we're going to start with factoring. And we get 2 solutions. And that's what we've been doing in the past. Algebra, we're going to move the 25 over. To cancel out the square, we're going to square root both sides. And we get both answers. It's the same 2 answers. Now the key thing to remember is when we put the square root sign with algebra, we get a plus or a minus. 2 possible answers. So same 2 answers, we can factor it, or we can use algebra. So I'm going to go back to the radical equations and show you that these equations are very similar to the current ones, the quadratic equations. So to get rid of the square root, I'm going to square both sides. And again, the radical has to be by itself. The number is on the other side, which we already have. So if I square, this cancels with that. And this one gets squared. So the first step is to get rid of the square root sign and then solve using algebra. Very similar with this one. We have to get rid of this, and the opposite is to square root. Now we can only do this if the brackets and the square is isolated. So notice the 25 is on the other side. We square root once we have this. So these cancel. And it's very easy. The x minus 8 comes out of the brackets. Square root of this is plus or minus 5. Don't forget the plus or minus. Now to get x by itself, we have to add 8. And we have 2 answers, but we have to figure out each one individually because we have a plus minus. So the solutions are x equals 8 plus 5, x equals 8 minus 5. And there's my 2 answers. So just to recap, whether it's a square root, a radical equation, or a quadratic equation, get rid of the square root or the square by doing the opposite. If we square root something, because we put the square root sign, it's plus or minus, and then we just have to work using algebra to figure out the 2 answers. So I want you to pause the video. Try this question on your own. It's very similar to the last one. Find the answer, and then check your answer. So for this one, first thing we have to do is get rid of this with the square root. The square and the square root cancel. Square root both sides, plus or minus 11. Move the 7 over. And the 2 answers, there's my 2 answers. So the key thing with this, it's pretty easy once we have the binomial squared, everything else on the other side, the 121 by itself. So as you saw, we needed the perfect square, which is right here, before we can do this algebra method. But a lot of times we don't start with the perfect square. How do we get that if we don't know all the numbers? So I'm going to show you with this example. If I've got x plus 5 times x plus 5, 5 times 5 is 25, 5 plus 5 is 10. We've done this in the last chapter. So the key thing here is normally we don't know this number. So we start with a 10 and we have to figure out how to get the 25. So we've got to cut it in half to get 5 and 5, multiply them together, square, to get 25. So if we look at this example, we've got to cut it in half and get 4 and 4. X plus 4, x plus 4. 4 times 4 is 16. Pause the video. Try the next one on your own or try B and C and see how you do. Okay, so this one we cut in half. We get negative 9, negative 9. Negative 9 squared is 81. I now have a complete the square. Now, if I factor this, I get that. And if I factor this one, that's what we're trying to do. We're trying to get the perfect square factored when we don't know that first number. So, I want to stress that complete the square is really good with even middle terms. We cut it in half, we square it, we find the number. Now the problem is it's a little harder with odd middle terms. Because if we split it in half, we get a fraction or a decimal. If we square this, we get another fraction. So the thing is we can still do it, but we just have to think a little harder and we have to work with fractions. So in this case, if we want to create the perfect square, if we factor it, we need to take this number and make the perfect square. So keep that in mind. We can still do it if it's an odd middle term, right there, but we end up with a fraction. Okay, so one more step in terms of difficulty. We're going to start with this. We need to figure out the perfect square, but we have a number over on the other side. We now have an equation with an equal sign. So we cut this in half, we square it, and we get 25. But the thing about an equation is if we add 25 to this side, we have to add 25 to the other side. So we factor the perfect square, add those numbers, and this is what we get. This is what we started the chapter with. So this is complete the square. If it asks to solve it, then we have to keep going. We have to square root both sides, move the 5 over, find the actual answer. But so far, if they ask for complete the square, this is all we have to do. So now try this one on your own. I've set it up just like the last one. Find the perfect square, create it, and then factor it. Pause the video and then check your answer after you're done. So this one we cut in half. We square, negative 7 squared is 49. Don't forget to add 49 to the other side. Now I factor the perfect square and I add these numbers. If they ask me to solve it, I'll keep going. I'll square root both sides. Okay, to look at both steps, we're always going to start with a quadratic function. Our first goal is to complete the square. We get the brackets with the square and a number on the other side. That's complete the square. The square is right there. And then once we have that, then we use algebra to solve it, to get the answer. So that's what we're going to do step by step. So if we start with this, the y becomes 0. The whole thing about this is y is 0. We're looking for the x-intercepts. We're going to move the 12 over because 12 is not the number for a perfect square here. So I'm going to add 12. And I'm leaving a space. I'm going to divide by 2. I'm going to get negative 4 and square it. So I've completed the square. Now I have to solve it. So I'm going to square root both sides. And don't forget a key thing, plus or minus. Now there's two things I need to do. The 4 needs to move over, and I need to simplify the radical. Is there any perfect squares that goes into 28? 4 times 7, so the 2 comes out. 7 stays in. And just to show it, 4 times 7 is 28. Square root of 4 is 2. And that's my final answer. I can't do anything more. I leave it in exact form. So once again, we start with this. We make the y 0. We complete the square. From there, algebra, we solve the equation. So I'm just going to remind you, this is ideal if the middle term is even. If it's general form, we've got ABC. It always works well with an even middle term. So this becomes 0. 9 moves to the other side and becomes negative 9. Now divide by 2, 7. 7 squared. We've completed the square. Now let's solve. So complete the square. Then we solve, and we have to simplify the radical to 2 root 10. Now this one's actually much easier. If it's given in vertex form, all we have to do, it's already partway done. We make y 0 and move the 9 over. And I always like my perfect square on this side, the number on this side. Square root, move the 7 over. And I get my 2 answers. Now, if it's a whole number when we take the radical, then we actually get the 2 answers. If it's not a perfect square, then we have the radical in the answer.